Hello everybody, today we're going to talk about our second part of lesson 2, which is combining like terms. So essentially what we're doing when we're combining like terms is we're combining things that are essentially the same, right? And we're just doing that so that we can make our list shorter. So here's just like a very kind of elementary example here, but if we were asked to combine like terms, obviously we would add together the cheeseburgers, right? Because cheeseburgers are the same, they're like terms. So if I have 2 cheeseburgers plus 3 cheeseburgers, that would give me 5. Here's my beautiful art, cheeseburgers, right? I know I can't take 2 cheeseburgers plus fries because they're not the same thing. We can only combine things that are the same. So then I would look for my fries. I have 1 fry plus 2 fries, so that's going to give me plus 3 fries. And then finally, I have my pops left, it looks like. I got 1 pop plus 2 pops, so that's going to give me 3 pops. Right? Combining like terms just means we're combining things that are the same to make our list shorter. So some terms that we have to understand, and I've used some of these already before, and you maybe already know what these are, but it's good to clarify. The first word is a term. A term can be a number. So if we just pick our favorite number, let's say we have 13. That's a term. It could be a variable. Remember, a variable is some, and I have the definition right here. It's some symbol. It's usually a letter that represents one or more numbers, right? It's some unknown number. So it's some variable. A lot of times we use X in math, but it really could be any letter. Letters that we generally avoid, though, are letters like S and L, because obviously S, depending if your handwriting's sloppy, that could look like a 5, right? That could be confusing. And L could look like a 1. So those are ones we generally avoid, but really it can be any letter. And a term could also be a product of a number and a variable. So it could also be, if I multiplied them together, 13x. Those are all considered terms. A constant, on the other hand, is just a number with no variable. So any number. So that could be 13, 47, 29, etc. A constant is just a number. A coefficient is a numerical factor that tells us how much. So, like for instance up here, this number right here, this 5 is a coefficient. It tells us how many burgers we have. We have 5. 3 is a coefficient. It tells us how many fries we have. We have 3. 3 is also another coefficient for the number of pops we have. So in like this example, if I just do 27x, the coefficient is 27 because it's telling us we have 27 x's. So if we just go ahead and go through some examples here, just identifying these key terms. First one is term itself. So if I want to list the terms in my example, remember it's a number, a variable, or a product of a number and variable. Well, here's one term, 6a squared. It's a product of a number and a variable. Another term is negative. Always take what's the sign in front of it. It's a negative 5ab. A third term is just 3b, and that's positive. And my last term is negative 12. Those are all terms in this expression. Next, we got to talk about constants. So, constants. Remember, a constant is just a number, no variable. So if I look here, the first term has a variable, has an a. Next term has ab, third term has b, but the last term, it is a constant, right? There's no variable, so my constant is negative 12. Then finally, my last term is coefficients. Remember, coefficients are in front of a variable and they tell you how much. So how many a squareds do I have? Well, I have 6. So I have a coefficient of 6. How many ab's do I have? Well, I have negative 5 of them. How many b's do I have? Well, I have 3 of them. And 12 is a constant, so it can't be a coefficient. So here's just a quick example going over those vocab words. So now that we have some terms kind of defined here, we're going to talk about what it means to combine like terms. In math, we can only combine like terms This means that in order to add or subtract two things, they must have the same variable raised to the same power. So for instance, if I asked you if 6x and 23x were the same, you would say yes, right? Because they have the same variable. They both have variables of x raised to the same power. Well, there's no exponent here. If there's no exponent, we assume it's a 1, so they're both raised to that first power. So we would be able to add those two things together. Whereas if I had 6x squared and 23x, yes, they still have that same variable of x, but the powers now are different, right? This is raised to a power of 2, this is raised to a power of 1, so I would not be able to add or subtract those terms. They're not like terms, so we cannot combine. So before I get into some actual combining, let's just do a few examples to determine if things are like terms. So this is a checklist you should go through in your head. Well, what's the variable for both of these terms? Well, the variable I see is x for both, so they're the same. What's my exponent? Both of them are 2, so that's why they are like terms. Whereas on this next one, what's the variable? Well, the variable for the first one is x, and the variable for the second one is y. So we really don't even have to look any further. They are not like terms, so I cannot add and subtract. They do technically have the same exponent, right? There's nothing there, so we assume it's a 1. So they're both raised to the first power. However, they're not like terms because the variables are different. On this last one, variables, both x, so that part's great. However, the first one is raised to the first power, and the next one is raised to the second power. So they are not like terms. Again, in order to be like terms, you have to have the same variable raised to that same power. So here's what a typical example would look like. It says try using different colors or shapes around the like terms to help. So that's what I like to do. I like to put like different shapes. Like for instance here, 6x, here's a negative x. Those are considered like terms because they have the same variable raised to that same power. So then I can combine those two. What's 6x technically minus a 1x? Well, that would give me 5x. Same thing here. If I have, right here it's a negative x squared. If I circle it or put a triangle around it, I always get the symbol with it that's in front of it, negative x squared. Here's another x squared, but this time it's 4. So negative x squared plus 4x squared would give me 3x squared. And lastly, if I just look at my constants here, constants are always like terms. I have a positive 3 and a negative 2. So 3 plus a negative 2, or 3 minus 2 is just a positive 1. So then I've gone ahead and combined like terms. I cannot combine anything left over because although like the first two terms have the same variable, they're not raised to the same power. So therefore we are simplified as it gets. So again, one more example here. If I'm combining like terms, I generally just start with the first thing they give me. And again, I like to use shapes just to kind of differentiate. 8x. So I gotta look for something else that has just an x raised to the first power, which I see right here with a positive or plus x. Again, there's an imaginary 1 there. So I think 8x plus 1x would give me 9x. Next, I come across, again, if I'm just going in order, see a negative 9, a constant. Do I see any other numbers that are just a constant? Yes, right here, a positive 1. So negative 9 plus 1 would give me a negative 8. Then finally, looks like I have a positive 2x squared. Do I see anything else with an x squared? I do. This negative 6x squared. So it's 2x squared minus 6x squared is a negative 4x squared. Notice my variable and exponent never change, just my coefficient out front telling me how many I have. Just like in that first example, when I added my burgers together, burgers didn't change, just the number of burgers I had changed. Again, I just like to use shapes to help me group my like terms and to differentiate. If you have a bunch of different colors, that works too. So now kind of combining everything we've talked about with the distributive property and combining like terms, when I ask you to write something in simplified form, that means no like terms, so what we just did today, and no parentheses, so like what we did before with the distributive property. So for example, here, this is not considered simplified because we have parentheses there. So you would have to go ahead and do the distributive property, which if I do that real quick, 2 times 3x is 6x. 2 times a negative 5 is negative 10. And 2 times a positive 4x is a positive 8x. Am I done with this problem? There's no more parentheses. Hopefully you're saying no because I satisfied that being no parentheses, but I still need to have no like terms. And notice I have a 6x and a 8x, right? They both have the same variable raised to that same power. So 6x plus 8x will give me 14x. There's nothing to combine that 10 with, right? That's just by itself, so we just leave it as negative 10 or minus 10. Again, in order to simplify, we cannot have any like terms and we cannot have parentheses. All right, why don't you go ahead and try this one and enter your answer into Edpuzzle. Your answer you should have gotten is 10x squared. They are like terms. They have the same variable raised to the same power. And then, so we just take 8 plus 2, which gives us 10x squared. All right, try this next one on Edpuzzle and enter your answer now. All right, if we check what you should have had for your answer, I start with 5x. What can I combine with 5x? Well, I can combine this negative 3x because they have the same variable. 5 minus 3x is a 2x. Right, next I come across a constant. I have this negative 3. Do I have any other constants? Yeah, I have this positive 4. So negative 3 plus 4 is just a positive 1. And then I have left this 6y. There's no other terms with just a y. So that means I just leave it as 6y. There's nothing to combine it with. So therefore this problem is in simplified form because there's no like terms and there's no parentheses. So this concludes our lesson today on combining like terms and essentially just simplifying expressions. As always, if you have questions, shoot me an email. Thanks.